Hi everyone. In the given problem statement, we have to evaluate reverse police notation. We are given an array of string tokens that represents an arithmetic expression in reverse police notation. Evaluate the expression and return an integer that represents the value of the expression. The valid operation are plus, minus, multiply, and a division. Each operand may be an integer or another expression. A division between two integers always truncates towards 0. There will not be any divisions by 0. So you don't have to take care of the edge cases. An input represented by valid arithmetic expression in reverse police notation. So whatever input that we are given, right, it is always going to be valid, and answer all the intermediate calculation can be represented in a 32-bit integer. So whatever you are getting right, our output will always come. That is what has been written up. Let us take this list. Okay, so we are going to have 2, 1 plus 3 and multiply. Now the first thing that we're going to do, we are going to define a stack. So initially, right, we are going to have 2. So we are going to add it to our stack. Then we are going to have 1, added it to our stack. Then we got plus. So once ever we get an operand, right, we are going to pop out the last two elements. So out here we're going to pop 2 plus 1, we're going to get 3. So we are going to pop all these two elements, and in the new stack, right, it is going to have 3, just 3. Then we are going another 3. So whenever we get an integer, just add it to our stack. Then we get an operand, multiply. So it would be popping the last two element, and 3 into 3 is 9. So 9 would be our output. Take an other example, which is 4, 13, 5, divide, and plus. So the first thing is that 4 and 13 I have added to our stack. 5 also I have added to our stack. Then we are getting our division. So once I get a division, right, so 13 divided by 5, we are going to get 2, because you have to take the lowermost value, because it's been written right out here. Division between two integer always truncates towards 0, so you're taking the lowermost value, and these two elements have been popped out. So the new stack is going to have just 4 and 2. Then you're getting a plus sign, so it would be 4 plus 2, popping the last two element. Answer would be 6. Similarly, we can do it for this long formation also. Now let us jump to the Python solution for the given problem. So the first thing that you're going to do, we are going to define our stack. So the stack is our list, and now we're going to loop it through our entire token. So for each in tokens, now let me add a try catch block. We can do it in a simpler way also, but let me add val. So val, if it's integer, right, so it is going to pass the try block, and not going to go to the except block, because you're converting the string. Let's say 2, right, we convert it to string. So we convert it to integer, it is going to be 2 string. If we convert it to integer, it would be just 2, right? But if, for example, there is a plus sign, right, and if I try to convert it to string, it is going to give an error. It is going to go to that except condition. So whenever if the value is string, right, we're just going to add it to our stack. So stack dot append our val. Else, right, if you're not able to convert to a string, then we can say it's an operand. So we are going to get two values. So stack dot pop the last two elements, and b would be stack dot pop. Now if our current value, right, each equal to plus sign, then our val would be int a plus integer of b. Elif each equal to the minus sign, then it would be val equal to int a or int b minus int a elif each equal to the multiply sign. In that case, the value would be val equal to int a multiplied by integer of b. Else, right, it's a division condition. In that case, it val would be int b divided by integer of a, because we are storing it in form of a string, right? So you have to convert it to integer. And at last we're going to do stack dot append our value. So one thing that we're going to do, we are going to add it in a str format. So string value. Once we have done that, let me return the output. So return once whatever the final value is present in the top of the stack, right? It is going to be final value. So integer of stack of 0. That's the final value. Let me run the code. Yeah, I made a mistake. Let me run it up. Okay. The first thing, right, in case it's going to return, right, in the division, right, it is going to return, it can return a floating point. So in that case, you have to convert that floating point to integer. So let me run it back again. I hope it should work now. As you could see, the public test case is passed, and let me submit the code. As you could see, the code submission got successful, and if I look into the time complexity of it, because you're looping through the entire loop only once, the time complexity would be big of n, which is pretty efficient for this type of problem, even though it's showing 9.91, but it's pretty good. So that's all for this video. See you in the next one.